Let's talk about putting models into drawings and adding dimensions. Um, as an example, I imported an old part that was created in a different CAD program. So this is number 15, but it was not made in Fusion. It was made in Inventor. And so I picked this on purpose so I could demonstrate a point. It's not oriented the way I would normally draw it, where it's lined up with the origin axes. So this is going to cause some issues when we put it into a drawing. So we're going to create a drawing from the design, and we're going to put it on regular size paper. Okay, so Fusion Drawings automatically start to place a base view for you, and it automatically picks the base view based on the front view of the model, and it doesn't give you options for changing it easily. So if I start projecting from this view, my top, front, right side, isometric, it's not giving me the correct views. And it makes changing them to the correct views pretty cumbersome, and it's not really worth the effort. So we're going to find an easier way to fix it the way it should be. We have to fix it in the model. So if I look at the model, this part should be the front, looking at it from that side. However, when I look there, as you can see in the view cube, that is actually the right. So let me find what should be the front. Okay, this should be my front view. And if I go here and right click on the view cube, I can set the current view as the front. Okay. And then if I go here to home, that's still not quite what I want. But if I go to front, I have reset that. But let's get the home set to where I would want it. Okay. Okay, so this is what I want the home view to look like. So I'm going to go up here to the view cube and right click and hit set current view as home. Fit to view means zoom in on it. So now if I click on top, it goes to the top. If I click on home, it goes to the correct home view. If I click on front, it goes to the front. So this is what I want. Now if I put it into the drawing, it's much easier to get the views oriented the correct way. So if I put in my base view, okay, since I made changes in the design, I had to go back and save it for it to update here in the drawing. And I had to click this link up here to update the newly saved file. And this little chain link tells me that it's updated. Since the file has been saved and updated, now when I project the base view into the drawing, this is the correct front view that I want. I can place it right there. From this front view, I can now project the top view, the right side view, and the isometric view. And remember, isometric views should be shaded. Okay. Now that I have all my correct views, I can start with annotations. This model has a lot of round and circular features. Round and circular features require center marks. There should be center marks on round features and on holes, such as these. Okay. And there should be center lines to show that where the centers of holes are. So I can select the two outer edges of these holes, and it'll put in center lines for me. And I'm seeing these holes as hidden lines. And also where you have arcs, you can put center marks on larger arcs, and then for smaller ones like this, we'll use a leader line on a dimension. Okay, so I have in all of my center marks. Okay, so here's an updated look with all the dimensions on here. So first thing to notice is this is a symbol for diameter, and the leader is pointing to that hole. So when you have a hole or a circular feature, you provide the diameter, but when you have a rounded feature that's an arc, you provide the radius. Okay, and then notice these linear dimensions provide the locations of the centers of these holes. And for this dimension, instead of repeating the dimension 3 times, I put that the diameter is 1 times 3, so that means for all 3 holes. Here, the radius of this fillet is 1.5, but it's times 2 corners. Okay. I have distances between the centers of these holes and the overall depth dimension. All the other dimensions can be inferred. So for example, here I have the height of the base plate and the height to the center of this circle. If I take this height plus the radius or the diameter, I can find this distance here for total height. And if I take the radius of this, it tells me that this is 4 inches wide right here. So I can find out how big this piece is, and the center mark tells me where the center of it is, so I can locate that as well, because this arc and this circle share a common center. Okay? And all of these dimension commands are found in here, so you can have a linear dimension, a radius or diameter dimension, which is the only things that have been used in here. Okay, and we'll get into more scenarios as we get into more complex parts. But for this assignment, since we're experiencing a little bit of frustration during remote learning, I'm not going to require that you put all the parts into drawings with dimensions. For this assignment due this week, you can just turn in the 20 models. We will cover drawing and dimensioning at a later time.